Hi, I'm Callie Carter, and I'm going to be going over what I've learned so far with modules 9 and 10, which includes chapter 10, 11, and 12. So chapter 10 was terminology and measurement and biomechanics, and this leads me to number 2, which I'm going to go and already do, which the difference between biomechanics and biology. Biomechanics is a study of mechanics limited to living things, especially the human body. And so we know that biomechanics has two components, which is biology and mechanics. In mechanics, you have kinematics, which is motion capture, and you have kinetics, which is force plate, the transducer. And in biology, it is the anatomy of the body, the physiology of it, how it functions, what muscles, what bones, organs, everything. And I like to think of it as like the input, which is your body and the muscles that are doing the work, and then you have mechanics, which is measuring the output of the work. And in order to measure biomechanics, we need to know what we're measuring, and that's how biology and biomechanics are measured, or how they are compared. You can't measure without knowing what you're measuring. And through that we have statics, which is all forces acting on the body are balanced, and dynamics, which is unbalanced forces. We learned units of measurement in chapter 10, which was mass, weight, force, time. We learned scalar, which is single quantities described by magnitude quantities, and then vector quantities is double quantities described by magnitude and direction, not just magnitude. Scalar is single magnitude, vector is double and magnitude and direction. And then chapter 11, we learned the description of human movement, which we learned the motions experienced by the human body, different types of motions. So motion is the act or the process of changing place or position with respect to some reference object. And cause of that is going to be some kind of force on the body, moving it forward and acting, or having the act or process of changing position or place. We learned that there's two kinds of motion. There's linear and angular, and that's going to kind of set us up for chapter 11 and chapter 12, knowing what linear and angular are. Linear is an object is translated as a whole from one location to another. You have curvilinear and you have rectilinear. Rectilinear is a straight line progression, and curved is obviously a curved translatory movement. And you have speed and velocity with this, and speed and velocity, the average speed is distance over time, and velocity is displacement over time. So distance is how much was traveled, and displacement is point A minus point B, how much. And then we have acceleration, which is the rate of change in velocity. We have final velocity minus initial velocity over time. That's going to be our acceleration formula. And then we also learned about angular kinematics, which is similar to linear kinematics. Angular displacement, which is 2 times pi times the radius. We also learned about angular velocity, which is the rate of rotary displacement, and which is omega equals the angle which the radius turns over time. Angular acceleration is alpha, which is final velocity minus initial over time. And we learned the relationship between angular and linear motion is if the linear velocity is constant, an increase in radius will result in a decrease in angular velocity, and vice versa. So they have that relationship that if there's an increase in radius, it will decrease in angular velocity. We have the formula, which is V equals WR, which shows the direct proportionality between linear velocity and radius. So then that leads me to chapter 12, which was conditions of linear motion. And we know through this chapter that weight is going to modify motion, and for every action there is an equal and opposite reaction to that. We learned about friction, and it's the force that opposes efforts to slide or roll one body over another, and the amount depends on the nature of the surface and the forces that are pressing them together, which leads me to the elasticity and rebound, which elasticity is the ability to resist, And that leads me to stress and strain, which stress is the force that acts to distort, and strain is actually the distortion that occurs. And we can see that the equation for elasticity is bounce height over drop height. Sorry, I forgot to mention that when I brought up elasticity. And then buoyancy, I am not sure how to pronounce that, but we learned that the Archimedes principle, which is a body immersed in a liquid, is buoyed up by a force equal to the weight of the liquid displaced. And density is the ratio of weight of an object to its volume. And that is just kind of a generalization of chapters 10, 11, and 12. There was a ton of information throughout those chapters. Those are kind of like the key points of it. I may have missed a couple things, but I was just trying to hit the key points that was important to each of those chapters. And so I went over 1 and 2, and I'm going to go over 3. How is this going to help me in my profession? I initially wanted to be a PT, and so this would have really helped me, but now I switched over to occupational therapy, and it will still help me, but not as much as it will help PTs. But OTs measure and treat movements and strength of upper extremities, trunk, just to help with ADLs, which is activities of daily living, hence occupational therapy. We will use biomechanics to understand the muscles and measure the output of those muscles, measure the output that the muscles are performing, and we can understand how the effect of gravity plays a role into the movement, and the effect that gravity has on our upper extremities and our trunk, and how gravity pulls us down, and we have to use trunk strength to keep our good posture, and that will help us in ADLs too. And then number 4, I would say that this is just a lot of information. I think I'm doing well in the class. I think I'm definitely spending a lot of time each day doing notes over the slides. It's just a lot of studying. Like, I can take the time to do the notes. It's just hard to study all of that information when I spent 3 hours doing notes on slides, and then it's like the overturn. It's like 3 hours studying. That's really hard for me to do. I think I just need to get better at spending more time studying the information and not just writing it down. I need to actually apply it, and not just, okay, I know what this definition is, I'm really good at that, but it's hard for me to apply that into a real life question or example. But yeah, I would just say that maybe little study guides, like I looked over the exam 3, and that is really helping me. I'm studying those terms specifically. So I would just say giving out study guides before each exam, and especially the final exam, so I know specifically what to study, because there is a ton of information and it would take a long time to just study all that information. So yeah, sorry, I kind of went over the time. I know it was 4 to 5 minutes, but this is 8 minutes. I try to talk fast, but yeah, I hope that I covered all the points that I needed to, and I know the information.